Alrighty, welcome everyone to day 2 of Advent to Code. Yesterday we got off to a very rough start with day 1. A lot of struggles, but here's hoping we get back to it here on day 2. Fingers crossed that the puzzle's not easier, but the solving is a little bit easier. Code, the base here, set up inputs, so once we get it, we'll drop it in here, and we'll be good to go in just a few seconds. Fingers crossed, solve goes better this time. Let's do this. 5, 4, 3, 2, 1. Let's get it. Alright. You're launched high into the atmosphere. The apex of trajectory just barely reaches the surface of a large island floating in the sky. You gently land on a fluffy pile of leaves. It's quite cold, but you don't see much snow. An elf runs over to greet you. The elf explains that you've arrived on Snow Island and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of walk, so you have some time. Don't give me a visit up here. Would you like to play a game in the meantime? As you walk, the elf shows you a small bag and some cubes, which are either red, green, or blue. Each time you play the game, he will hide a secret number of cubes of each color in the bag, and your goal is to find the information about the cubes. The information, once a bag has been loaded with cubes, the elf will reach in the bag, grab a handful of random cubes, show them to you, and then put them back in the bag. This is a few times per game. You play several games and record the information for each game. It's the puzzle inputs. Your game is listed with its ID number. K followed by semicolon. Fair enough. Separated. The subsets of cubes are revealed. Gotcha. So it'll kind of look like this. What's the semicolon again? The list of subsets. Gotcha. Okay. In game 1, 3 sets of cubes are revealed from the bag and put back in. The first set is 3 blue cubes, 4 red cubes. Second set is 1 red. Gotcha. To know which games would have been possible if the bag contained only 12 red cubes, 13. Gotcha. So they're not put back until the very end, right? Oh no, okay, we'll pull them out and put them back in. Gotcha. So... okay, so we just need to find what games are impossible. This one seems pretty straightforward. That's the wrong project. This one seems pretty straightforward here. So let me go ahead and just go input. I can type input, and we'll split again on new lines. And then we're gonna go ahead and reduce. Because we're going to call this a sum and then a game, because we just want the sum of IDs for this. Okay, and then we're going to return sum for now, but the point here is we're given this so we can, I guess we can split it. I'm trying to do the best. Let's just do oh no, let's call this line, not game. Equals line substring with 0. Actually, let's call this is it a colon or a semicolon? It's a colon, okay. So the colon index is going to be equal to line index of the colon. So we're going to get this, and we're going to do a quick substring here. This gives us the game string, and then we're going to get the roles here. I'm going to go ahead and trim this real quick just to make sure it's a little bit better. And actually, we can go ahead and just we can go ahead and split this on the semicolons. Let's call this actually subsets. And so this will give us the subsets, and then what is 12 red cubes, 13 cubes, 14 blue. Okay. So what we need to do is actually need to go through all the subsets, and we need to make sure that they're all valid. I'm not sure the best way to do it. I mean, I can just do... Just do a nice resolve. Okay, we'll do another reduce here. Oops. Valid. Go ahead and do another reduce, and this is going to be V, and then this is the subset. It'll start off true. All right, I'm going to call this invalid. Invalid's a little bit easier to do. Start off as false. So what we're going to do is then we're just going to turn V. This will be in just a second. So for each subset, this is going to just be this. We'll go ahead and do subset, just to trim real quick, just make sure, and then we'll have it split on commas. And so this is going to be the die. And then we need to understand, so we can then split each one on spaces. Oops. Let's go ahead and split this again on spaces. So now we have the die, which is going to be a string and a string, right? Am I gonna do another reduce again to do a validity check? Yeah, I guess we are. So this is going to be V2, and this is going to be the die count, and then we're going to return V2 again with some ors, false, and it's going to be const. Okay. I guess I could. That's fine. Okay. So what it's going to do is we're going to do die count 0. So this is invalid. So if it equals red, we'll do one check. So if it equals red, then we need to do a parse int. Actually, I'm going to do the const count equals parse int here on the die count, the first index, because that's going to be the number. And so it's going to be count. Invalid means the count for red is greater than 12. Otherwise, green and then blue, we won't. I'll just do this. Green's 13, blue's 14. Easy enough. Green 13 and then 14. So this will return if it's invalid. This will return here if the whole subset is invalid. And then if the subset is invalid, we'll go ahead and do invalid. If it is valid, we'll do 0, so worry about. If it is invalid, now we need the game number, which is going to be equal to parse int. I can actually do a -1 of game string index of a space. Oh, sorry. Substring first of the index. Okay, there we go. So now I have the game number, so I can actually go ahead and put that there. And in theory, I don't know. Let's just see what we get here. I'm curious. Probably not a number. Yeah, we're gonna get not a number in there somewhere. I'm gonna bet that this is wrong, the game number here. I have a feeling that I didn't substring this correctly. Something. Oh, there's probably gonna be a space in front of it, isn't it? Yeah. What? Okay. Oh, cause right, it's not inclusive. Right. But this needs to be. No, is that fine? Oh, I need to get rid of the space. Right. Oh, it got it for me. Okay, let's just get, just... No, okay. I could hope. I'm actually gonna do the test input quick. Always a good idea to throw the test input through. I can get rid of that. So we'll do game. We're gonna do this real quick. We're gonna do game number, and then throw if it's invalid or not. So what we're looking for is 1, 2, and 5. So 3 and 4. Oh, that worked. So it should be 7. That's the wrong project again. Oh, we get 8. What? Oh, would have been possible. I did it backwards. I did it backwards. There we go. Now we get 8. Now we can throw this back in. It's still not right though? What? Alright. Let's throw that back in. I'm gonna flip that just so I can visually see. So now we can go through all these and get to kind of like manually check. Is there a case where it throws another color in there? Let's do this. Let's do one more. And this is gonna be blue. Do that, and then we'll do that. Does that change it at all? What? 0. Whoa, wait. What did I do wrong here? These are backwards. How did I even get this? All right, the fact I got this right when these are all backwards is beyond me. Huh. How to get the I got the test input and that's still wrong. All right. All right, this is going to be a bunch of spam, but I just want to make sure. Just want to make sure that these are all some non-numbers. Good. That would be why. Why are these not numbers? What the? Trim on the commas. Okay, what if I just throw a trim on this? Right, why is the 1? Do I need a trim on this? There we go. Okay. Now we're in business. So 2156. Okay. Now we're in business. There we go. Okay. Parsing text is hard sometimes. For part 2, the elf says that they stopped producing snow because they aren't getting any water. He's not sure why the water stops. However, he can show you how to get the water source. Check it for yourself. Just ahead. You continue to walk. The elf proposes a second question. In each game you played, what was the fewest number of cubes of each color that could have been in the bag to make the game possible? Game 1, the cube. A game could have been played with as few as 4 red, 2 green, and 6 blue. The power of a set of cubes is equal to the number of red, green, and blue cubes multiplied together. Okay, so that's part 1. Part 2 is similar, but instead of this, for each game we need to find the max. So let's do this. Okay, so we're not going to return this. This is going to be colors. And it's going to start off as red, 0, green, 0, blue, 0. And what we're going to do is return a new one of red equal to colors, red, math dots max of this plus the one we're currently on, and we're going to do it for each of these games here. So now what we have is we have these oh wait, this go wait. No, sorry, my bad. This goes in here because this is the actual individual games. Right. So there's the count. It's the subset. Right. Fine, because yeah, this is each individual. No, I was right. Because this is each individual game. Right. Okay, no, I was right. Okay, I was right. So what is this? The die. This is the individual dice roll we're getting here. Yeah, this is the individual die of this. Right. So we want, I guess I can do it here. I can I can extrapolate it from here. So I can return let's call it colors 2, and then what we'll do is we'll do die count 1 with the count, and that will get me the individual colors for this, and this is going to be the subset colors, and so I can do subset colors dot red, subset colors dot green and blue. Okay, and so this is going to be color max. And so now with the color max on each subset, this is where we get to the actual question, which is the power of a set of cubes equal to the number of red, green, and blue colors multiplied together. The power of the minimum set of cubes in game. Okay, so we just multiply them all together. Do I still have that? There I do. Okay, get rid of that. So it's just me sum plus color max dot red times color max dot blue times color max dot green. I'm gonna just do the test here again because I don't trust this logic to be at all correct. What was the answer? 2286. I got 2256. That's kind of close. 48, 12, 48, 12, 156. Wait, I'm actually 630. Wait, why is the last one 6? Why is the last one 6? 1, 2, and 3. Should be 6 red. That's the wrong thing. I keep on this project. Okay, so it works, except because it's not reading. Yeah, 6 and 20. Yeah, it's missing this first. Okay. So I have a small bug that it's missing the very first, which should be easy enough to figure out. What's going on with subset here? There is a semicolon in it. Did I just get lucky in that this didn't care about it? I think I just got lucky in that I didn't have a question that needed to care about that. Fair enough. Okay, so if I get rid of that now, and I go back to my actual input, I should get a real answer, and that real answer should hopefully be correct. Hey, look at that. All right, 1 second, we'll go over the solution here. Alright, so day 2 is actually not that bad. The whole point of today's is that you're given these kind of grab bag style where you're just grabbing dice out of a bag, and for part 1 you're trying to determine which games are invalid because you're pulling more dice out of the bag than there actually are in the bag, if that makes sense. So to accomplish this, we simply go through all of our input lines. We are first parsing out this bit here, the game one bits, and then getting the string here, and actually getting the game number. That way we can use the game number for the actual answer, which is summing up all the invalid games, or sorry, summing up all the valid games, my bad. And then the second half is then all of these is the actual subsets of each game. And then from that, we go ahead and split it on the semicolon here. So we get each individual subset of the game. And then we split on the comma here. So we get each individual dice counts, which can be found here. Here's the subsets where we split it off that. And then what I do is I reduce this again by going through all the subsets and again, split them on the comma here with some trimming here. And actually, I split it once more to get the individual parts, so I get the 4 in red, 16 in green, so on and so forth. So that's what this dice is here. And then again, once more, I do a reduce, which is all it's doing is it's getting the count of the die, and then what the color is. And so it's checking is if it's red, is the count more than 12? If it's green, is it more than 13? If it's blue, is it more than 14? And it's using this reduce because if it's true, this return will always be true as soon as any of these cases are true. Hopefully I said that makes sense there. But I'm checking for the invalidity of the logic. So as soon as any of the subsets are invalid, that whole game is invalid. So that true value kind of bubbles up because we keep doing the value or new stuff, and if as soon as it becomes true, this reduce will keep returning true through all of them, and then that's how we get if a particular dice is invalid of a subset, and then we use that same logic again on the individual or on the specific game logic to know if a game is invalid because one of its subsets is invalid. And then using that, we can check if it's invalid. We don't add anything to our total. If it is valid, we go ahead and add the game number to our rolling sum. And that's how you get part 1. Part 2 is similar in the fact that we do all that that splitting and parsing of our inputs. But what changes here is that instead of bubbling up if a game is invalid, we're bubbling up the max red, green, and blue values. So again, here is the actual individual subset. So for each subset, we're reducing the individual dice rolls to just get the red, green, and blue values kind of as a more pretty value, but also in its own better kind of controlled object. I feel like I could have done this a little bit better and not need to reduce, but kind of whatever. But then using that for each of the subsets, now that we have it, we're now bubbling up the max of the each individual color. So from a given subset, we get the red value, put it into a max function with the current max value of red, green, or blue in this particular game. And again, this then gets bubbled up into this color max, which again is thrown into the function they give us for the power. I think it was called the power number, which is the red times blue times green, with all those summed up again in one more reduce, which bubbles up into our part 2 answer. So I hope you know how reduce works in TypeScript and JavaScript, because I use it, not really abuse, but I use it heavily here. So it's a pretty powerful function if you understand how reducing works and how it kind of sums or bubbles up its return values from each individual lambda function it calls itself. But yeah, there we go. Day 2 was not too bad, but it was definitely much better than day 1 yesterday. So anyways, that is all. I'll see you guys all tomorrow for day 3. Peace out.